So I'm showing you how to make the model for the globe with the lines of longitude. So what I did was I took Vivian's idea and I used a rubber band and I put the north and south geographic pole, and then I put the rubber band through so that I could get the lines right. And then I did another line that is 90 degrees. So that's the first step. So as you can see, I'm doing the next line and I'm putting it between these two other lines, and I'm making it so the edge of the rubber band goes through the top and bottom, the north and south geographic pole. Then I'll just make my line right next to that rubber band. Okay, so I made that line there, and now I need another one here. See, these are quarters, 90 degrees, and I need one to bisect that 90-degree angle. So I'll move my rubber band over here. So you see, when we look at our model, we know we're going to need 24 lines total. So we already did the one straight down in the middle and the one on the edge. And now we just did the one here, which is 1, 2, 3 over from this one, and 1, 2, 3 over from the edge. So here I have the next line that I'm going to draw. So we had 4 sections, and then we bisected these 2 across, and now we're going to bisect this last 4th section. So that will give us 1, 2, 3, 4 lines, and we're going to need 12. Okay, so they're really not lines, they're circles, but we have 4 of them. 1, 2, 3, 4. See, because this one is connected here. So now for each of these pie-shaped regions, we need to put 2 lines inside of those. So let's do that next. So this is going to be broken into 1/3. So just to sort of give you an idea without doing all the lines, I broke this pie section, which is 1/8 of the whole 360, and I broke it into 3 sections and added 2 more lines. So if we have eighths here, we have 4 and then 4, and then we break those into 3 sections, then that means we have 24 sections. Okay, so let's go over what we did. We first made 1 circle around, and then we made a 90-degree circle around, and then we took those and we broke those in half. So we made this line here and this line here, and then for each pie section we made 2 lines inside. So let's count to see if we have 24 sections and 24 lines. We'll start with this long one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So now we have 24, and I can use my rubber band to finish all of those lines. So with each one, I'm going to move it over just to be on the line, and then put my rubber band there so I can make that line. Okay, I just finished drawing my last one, and I just used the rubber band as a guide to do that. So let's look and see what happened here. Sort of like orange slices, and you notice how they're smaller when you get to the poles, geographic north and south, and then the spaces between get larger as you get to where the equator is going to go. So next we'll put the equator. It should be easy to figure out where that is. You just do half. So I put my rubber bands around to make the equator line at half. So I'm going to make the lines now. So I wanted to measure the distance around the tennis ball so I could do these angles. And I cut a strip of piece of paper to do that. So now I know the distance around the tennis ball, and I'm going to measure that. So I have my dot for my center of my circle. It's on the middle, and then my radius is set to 3.2 centimeters, and then I'm going to put my pen right in that hole right below the 3.2 centimeters and make a circle. It's probably better to see it from up above. I want to just sort of flatten it out so we can draw the angles. So you see I'm making this smaller, but the same principle applies that we're going to do over here. We look at the protractor, and where is 15? Where is 30 degrees? Where's 45 degrees? 60, 75, and then we're going to make notation so we can make the lines and figure out where my lines of latitude are going to go. Alright, so I put these markings on here so that you could see how to figure this out. So for the 15 degree one, it's right out there. So I'm going to make a straight line between the center of the circle and where I notated 15 degrees was. And then I'm going to mark that on the edge of my circle. And I'm going to continue with the rest of them too. So here's the next one. Here I line that line up. And that was my 30 degree mark. And then I make a mark here. And I continue doing the same thing for all of these marks that I made based on 15, 30, 45, 60, and 75 degrees. I even have one straight up for 90. So now I went ahead and labeled all those, so you know the next step is to draw the lines that connect the two 15 degree north lines. So now I've just approximated that for my tennis ball, so I know where those lines are going to go and what they're going to look like if I looked at them in a flat way. And I'll do the same thing going down to the south, to the lines for the south. So you see I made a mistake there. I started to label the equator, but the equator is 0. So then when I go down one, that's 15 degrees south. So try not to make the same mistake I did. So I found an easier way, and I noticed that between all of these on the outside edge, it's about 0.8 centimeters or so 8 millimeters. And I can just use that to make the marks of where the lines of latitude are going to go, and I'll just make a specific measuring tape just for that. So I have made little marks about approximately 8 millimeters apart, so I can use that to mark the places on my tennis ball where I need to make my marks to do my lines of latitude. So I'm going to put on there. It's a lot easier. And then I'm going to make a mark on the tennis ball, and that's where I'll make my line. So here I even included the lines of latitude so that I'll know what to label them. So as you can see, I used my little invented tape measure here to make marks around in my northern hemisphere of where the lines go of 15, 30, 45, 60, and 75. And then of course this is 90. And now I'm going to connect all my lines, and I'm going to use my rubber band as a guide. Okay, so I did use the rubber band, I must admit, for the first line, and then after that I sort of eyeballed it based on those markings that I made. So let's look at how the lines of longitude that we did first were like the orange slices, but then the lines of latitude, they are concentric circles. So all the lines of longitude are congruent, and you know, they're all the exact same size and the exact same shape because they're all the circles, which is the greatest distance around the tennis ball. But then when you get to the lines of latitude, those circles are of different sizes. So we'll keep this in mind as we use this as a model when we make our actual paper mache globes. So we have those there ready to paint. And I'm going to do the same now with the southern hemisphere. So there you have every hour as the Earth spins on its axis at its slight tilt. Each of these represents 1 hour. Now, are there just 24 lines of longitude? No. How many degrees in a circle? 360. So there are really 360 lines of longitude, but we just have 24 here. So they start at 0 and go 15, 30, 45. If we go this way, we're going east. If we go this way, we're going west. So we could pick any of these lines to be the prime meridian. But let's say we pick this line to be the prime meridian right here. That means that the line directly on the other side is going to be what? If this one is the prime meridian, then this one has to be 180 degrees that doesn't have an east or a west.